Solve the ordinary differential equation by the method of variation of parameters. So we have y triple prime minus y prime equals t. So the solution of this non-homogeneous linear ODE is given by the sum of a complementary solution and a particular solution. So first we find the complementary solution. For we consider the homogeneous part, just left hand side equals 0, and we solve this homogeneous equation by finding characteristic equation, and which is r cube minus r equals 0. Now we solve this equation for r, so we can factor r out. R squared minus 1 equals 0. So r equals 0 and r squared minus 1 equals 0 gives positive 1 and negative 1. So we have three zeros. Based on these three zeros, we have e raised to 0t, which is 1. So the first solution is 1. And y2 e raised to t. And y3, that's e raised to negative 1t. These are three solutions of this homogeneous equation. Then we can write down the complementary solution. yct is c1 times first one plus c2 times second solution et plus c3 times the third solution. Okay, this is the general solution of this homogeneous, and that's the complementary solution for our non-homogeneous. So this is yct. Now to find a particular solution, we just vary these constants c1, c2 and c3 by functions u1, u2, u3. Then a particular solution is given by the c1 will be u1, which is to be determined, plus u2 et plus c3 is now u3 e raised to negative t, where we have had to find u1, u2 and u3, and the sum of this complementary and particular will be the solution of this given non-homogeneous equation. So where we find u1, u2 and u3, and we know that the ui is given by this integration, so gt times wi Wronskian over Wronskian of these three functions. Okay, Wronskian of y1, y2, y3. Let's write wt dt, and this is for I equals, in our case, 1, 2, 3, and this gt is the non-homogeneous term. If you go back, look at the question, this right hand side t, that's the g part, by the way. And u1 is w1, that's the only change, and w is the Wronskian of all three solutions here, 1, et and e to the negative t. And u2, that's the second unknown function, is same thing with w2, and I'm going to find these w1, w2, w3 and w here. Okay, and let's find w on the side here. The Wronskian is the Wronskian of our three solutions, 1, et and e to the negative t. To find the Wronskian, we write those three functions on the first row, find their derivatives on the second row, again find the derivative of this in the third row. Now we expand, we find this determinant. Okay, so we calculate this determinant in this way, and as we know, when we have 1, 0, 0, so let's expand along this column, or we could expand along this row as well. So 1 is there, and 0, 0, we don't have to even expand about those two entries, just 1. And now we delete the row and column containing 1, write down the remaining 2 by 2 determinant. That's now et minus e to the negative t, et e to the negative t. Now 1 doesn't count, multiply et times e to the negative t, 1 minus, here is negative 1, so 1 minus negative 1, which is 2. So this determinant is 2. Okay, so for all three functions, come back here, for all three functions u1, u2, u3, we need w of all these solutions, all three solutions. That's 2. So this is 2. Now we need to find u1, u2, u3 means w1, w2 and w3. So w1 is the same determinant, replace the first one, means first column by 0, 0, 1. So we replace 1, 0, 0 by 0, 0, 1. And w2 is same, but we replace second column by 0, 0, 1. And w3 same thing, but the third column will be now 0, 0, 1. Okay, so let me calculate w1 and w2. So the w1 is just this determinant, but the first column is replaced by 0, 0, 1. Again, we can, this is plus, minus, plus. If we want to expand along first column, then it goes with plus, minus, plus. So let's expand along 1, because expand along 0, 0, just 0. So 1 there, delete the row and column. So et, e minus t, et minus e minus t. And find this 2 by 2 determinant, and that comes out to be negative 2. Now next we find w2, and we need to find w3 as well. Okay, so w2 is here, which is w, but the second column is now replaced by 0, 0, 1. Again, let's expand along this first column, and then we don't have to go for these two elements, just 1 times we delete the column and row. So the 4 elements cross, like multiply 0 minus this, so this is e to the negative t. And w3 is w that we've seen earlier here, same w, but the third column is replaced by 0, 0, 1. Let's expand to compute this determinant. Let's expand along first column. So 1, then we delete the row and column. So et0, et1, and find this 2 by 2 determinant, multiplying this minus this, so just et. So we have now w as 2, w1 is negative 2, w2 is e to the negative t, and w3 is et. Now we are ready to find u1, u2 and u3. Then a linear combination of u1 times 1, u2 times, here you go, that's the u1 times 1, and that gives us a particular solution, and the sum of particular and complementary here, okay, yc, and that will be our final solution. Okay, now u1 equals integral of gt w1 over w, and gt is the non-homogeneous term, that's the right hand side, which is t times w1 was found above negative 2 over w was 2 dt. 2 and 2 cancel, negative 1 outside negative, and antiderivative of t is just t square over 2. Okay, in the same way, u2 is integral of gt, which is t, times w2, which is e to the negative t, over w is 2, and we can take 2 outside, 1/2 integral of t times e to the negative t dt, which is a product of two functions, t and e to the negative t. Now to determine this integral, we use the integration by parts. U is t and dv is remaining, u times dv. By integration by parts, so you do this part, integration by parts, we get 1/2 outside. Okay, this integral is negative t e to the negative t minus e to the negative t. Okay, and let's find u3, and u3 is gt, that's t, times w3 that we found et over 2 dt. Okay, that is this 2 we can pull outside, 1/2, and now t times e to the t dt. This is also a product of two functions, so we need to use integration by parts. So IBP, integration by parts, 1/2, and this do on side, you get t e to the t minus e to the t. Okay, now we have u1, u2, u3. Then let's go back and plug this in to find yp. Okay, thus a particular solution was u1 plus u2 et plus u3 e to the negative t, which is now, we just found u1 to be negative t square over 2. This is negative t square over 2, and u2 was here, and we multiply with et. So let's multiply u2 by et here, multiply by et, then et times e to the negative t, 1, so negative t minus 1. Okay, so the whole thing now becomes 1/2. When we multiply inside, negative t minus 1 plus u3 is here. Now we multiply u3 by e to the negative t, then 1/2. When we multiply inside, et times e to the t, e to the negative t times et, just 1 minus 1, so 1/2 outside, t minus 1. And let's simplify this, which is negative t square over 2. Here now, when we distribute, 1/2 minus t, so minus 1/2 t is positive 1/2 t, cancel. 1/2 times negative 1, negative 1/2, here is 1/2 times negative 1, another negative 1/2. So 1/2, 1/2, minus 1/2, minus 1/2, we get just 1, minus 1. So that's yp, and hence the solution y is complementary solution plus particular solution, and this yc was c1 plus c2 et plus c3 e to the negative t, plus we just found yp here, negative t square over 2 minus 1. We can simplify further, by the way. This c1 minus 1, that will be a new constant, right? So c1 minus 1, we can say c4 maybe, or any other constant, it doesn't matter, because c1, c2, c3 use c4, and remaining plus c2 e to the t plus c3 e to the negative t, and this is minus 1/2 t square, final.